right, 5-2. All right, for this one, last class I told you guys to write something else. But you need to know if it's equal, if it's congruent, if it's the same size, same shape, they're going to have the same side measurements, and they're going to have the same angle measurements. Does anybody remember what does the measurement of the inside of a triangle equal? 180, it has to be 180. So if they're giving me two measurements over here on both sides, I can assume I know what the last one is because it's equaling to 180. So using the information from 5-1, you should be able to find the third measurement. But looking at this, all corresponding parts on a figure are congruent to the corresponding parts on the other one. What does that mean? It's, like I said, it's like a matching game in some sort. I have congruent sides. We have to know what congruency marks are. So all of these little ticks and curves are my congruency mark, and it's like a matching game. It's a pattern. So one that has 1 mark is congruent, the one that has 2 marks is congruent, and 3 marks is congruent. It's going to be some sort of pattern. So in order for me to tell that a triangle is congruent, I have to be able to state all 3 angles are congruent and all 3 sides are congruent. So looking at this one triangle, I have to find all 3 corresponding. If you want to write it in white, small on your slides, because I know you guys can't like zoom out, you could always use that tool to make it smaller. So all corresponding congruent angle pairs. We're going to find all the pairs of angles that are congruent. So does anybody want to give me a guess on which ones are congruent? So angle A is congruent to which angle? Is congruent to angle F. It's in red. So looking at it, this angle with one congruent mark is congruent to the other. Angle B is congruent to which one? Angle E. And then looking at the last one, C is congruent to D, and I'm just going to write it out so we know how to write angles. Angle B is congruent to angle E. And green won't really show up, so angle C is congruent to angle D. So I just stated all 3 angles are going to be congruent. Now I have to state the sides. Okay, so I need to state 3 corresponding sides that are congruent. So when I'm looking at this, same thing we did with the angles, my sides are going to be congruent, and you have to know how to write your sides. So we had lines, we have segments, and we had rays. You have to make sure you're writing these correctly. So looking at it, A to B is one side. So I have A to B is congruent to what? What is it congruent to? Good. FE, again, you could write EF, same thing. FE, and because they're sides from one point to another, I'm going to write my segments. Then I have BC is congruent to ED. And then the last one is AC is congruent to FD. So we're just matching sides with angles. Again, in order for a triangle to be congruent to the other triangle, you have to state the angles are congruent and the sides are congruent. So when I'm looking at this, you have to know how to write a congruency statement. So for this one, my statement would be a triangle ABC is congruent to triangle, that is not a triangle, FED. In order for you to check this, you're matching it up. So when I'm looking at this, I have this one following it through. ABC going from top to bottom, FED, and then I could look over here. It's the same, ABC to FED. And I could also match the sides. So when I'm looking at it, I have side AB, FE, which is right here. I have side BC, which is right here, and ED. So again, matching them, they're in the exact same position. And then AC and FD. So when you're looking at it, again, you're kind of matching them together. Okay, I could again also match my angles. So when I'm looking at it, I have AF. Here's my A and my F that go together. And then I have my B and my E that go together. And then lastly, I have my C and my D that go together. So it's, again, can we all see the matching pairs? They're written in the exact same order. It's going to be the same. So they are congruent triangles. Does everybody understand that? Does it make sense? It's the exact same thing. Okay. On to the next one. If two angles of one triangle are congruent, then two angles of another triangle, then the third angle is also congruent. So for this one, if the three angles are congruent, then my sides will be proportional. So that's what we kind of wrote last time. But just giving you an example, if this corner was 20 degrees, that's telling me D is also 20 degrees. And then if angle B was 100, B would also be 100. How would I find the measure of angle C? How would I do that? I would add them. 100 plus 20, and what's 100 plus 20? 120, then what would I have to do with that 120? So 180 minus 120, and what would I get? 60 degrees. So if they're always giving us two measurements, two angle measurements, we could always find out the third angle measurement. We will always be able to find the third measurement, okay? You have to know this theorem. This is super important. You guys will get at least one proof on your test. And this will definitely be in there because it's dealing with congruency of triangles. So you could write this, you can shorten it if you want. You could write it as third angles theorem. Okay, that is the theorem you have to know. Third angles theorem. Super important you know it. If I know two angles, I should be able to know the third. Questions on this?
Okay. On the test, we have to write the theorem?
I would definitely give you multiple choice for the theorems like you've had before. I would not have you guys fill it in. All right, looking at the next one, we have seen this before. We have answered these. We have reflexive property, symmetric property, and transitive property. We've done these like so many times throughout the lessons, throughout the chapters. Reflexive property just means it's the same. If it's equal to itself, it's going to be equal to itself regardless. Symmetric property, you're just writing it different ways. You're just flipping them. AB is congruent to DEF. Then triangle DEF is congruent to ABC. And then transitive property, we know we're getting rid of something in the middle. So if ABC is congruent to DEF and DEF is congruent to JKL, ABC is congruent to JKL, so you're really just getting rid of what's in the middle. All right, examples, we did some of these, but I want to clarify on a couple of them. So an acute triangle is blank congruent to an obtuse triangle. Is that true or false? Or always, sometimes, or never? All right, this one's going to be never. Let me get a pen. This one's never. A polygon is congruent to itself. Always. A right triangle is blank congruent to another right triangle. This is sometimes, and I want to show you why it's not always. So looking at these two triangles, I'm going to draw. Here are my two right triangles. My other two angles, my other two acute angles have to equal what?
90 degrees.
Good. The other two acute angles have to equal 90. So I can have 45 degrees, 45 degrees, and then this one, for all we know, we could be 30 and 60. So looking at these are two right triangles, but they're not congruent, okay? They're not equal. They're not the same. So sometimes right triangles could be the same. So again, if I were to draw another one, another right triangle, and 45 and 45, yeah, obviously they're equal, but my answer for that would be sometimes. Looking at the next one, it says if triangle ABC is congruent to triangle XYZ, then A is blank congruent to Y. What would that one be?
Always.
This one would be sometimes. Why would it be sometimes? I'm going to show you why. Because remember, you are, like we said, matching our pairs. So when I'm looking at this and we're talking about A and Y, my A is right here and my Y is right here. Is it in the same position? No, they're in two different positions. However, the reason why we're saying sometimes, if they were to give you a right triangle, that looks something like this, your A, let's say A was right here. Let's say this was A, what? B and C, and this was X, Y, Z. Could your A be equal to your Y? Would my A be equal to my Y? Yes, because they're both 45. So that's why this one is going to be sometimes. They're sometimes congruent. If it's the same measure, obviously it's going to be congruent. But for example, if they were to give me this one and this one, it would obviously be never. Okay, if they were to say this one's X, Y, Z, it would be never for that. But the reason why we're saying sometimes is because these two are congruent triangles. So looking at the next one, if triangle ABC is congruent to triangle XYZ, then A is blank congruent to X. What would that one be?
Always.
That one would have to be always because it's the exact same position. A is first, X is first, and they're congruent. They're going to be the same measure. So again, it's like a matching game. All right, looking at this example, we should be able to use this example to find out the rest. So looking at this one, it says in the diagram, ABCD is congruent to FGHK. Find X and find Y. Who could help me with this? Matching my sides. What do I know is congruent? What do I know is going to be the same measure? How can I find this? What do we know? Someone helping me out. I need to solve for X. What do I know about GF? It's congruent to which side? Good. This side right here is congruent to this side, which means this angle is equal to what? GF. Good. GF, I'm going to write it out. I will use white. Or FGGF is congruent to AB. So I can set it up as 3x minus 6 equals 9. And how would I solve for x? What do I have to do? I'm going to add 6 to both sides. I'm going to get 3x equals 15. Divide both sides by 3. X equals, good, x equals 5. All right, now they want me to solve for y. I found the answer for x. What do I know about angle K? What do I know about angle K? Angle K is congruent to what? Angle K is congruent to angle D. So let me highlight that. It's 44 degrees. And they're also giving me x in there, so what do I have to do with that x? Good, I'm going to substitute, I'm going to plug it in. So I have 4x plus 2y equals 44. And I'm going to take this 5 right here. And I'm plugging it in for x. So I have 4 times 5 plus 23 equals 44. And I'm solving for y. So I'm going to get 20 plus 2y equals 44. Subtract 20 to both sides. 2y equals 24. Divide both sides by 2, and y is going to equal 12. Good.
So if we have a question like this on the test, we always solve for x first?
Obviously, like this one, it says solve for x and y, and they're giving you one with both x and y. You have to find x first. I can't just go in here and start solving for y because I have an x there. So yeah, you would have to solve for x first, and then plug it in, and then solve for y. Questions on this one? All right.
Is this lesson on the test too?
Yeah.
I thought it was only 2 lessons.
It is chapter 4, which was transformation, and 5.1, 5.2. Okay. Looking at this example, it says Maggie took the piece of fabric STUV shown in the diagram and cut it on the diagram to make a scarf for her and a friend. Are the two pieces the same size and same shape? What do I have to find for triangles to be the same size, same shape? What do I have to find? I have to find 3 corresponding sides and 3 corresponding angles. So looking at this, they're giving me information, but now it's for me to state what's congruent and what's equal. So I'm going to find my sides first because looking at it, I can tell which sides are congruent. So I'm going to do my 3 congruent sides, or we'll do side pairs because there are pairs. And who could tell me which side pairs are the same? I can definitely tell just by looking at it because they give me some congruent marks. I have one over here and one over here, so I can tell that those are congruent. So I'm going to write them down. How would I write those sides?
SV and TU.
Good. SV is congruent to TU. Also, if you wanted to write VS, it's the same thing. Looking at it, I have 2 congruent marks here. ST, I'll write it in white, is congruent to VU. And then what would my third one be? Because they share a side, that is going to be congruent. Okay, they share the side, it's the same, it's equal. It has to be equal because they're sharing it. So what side would that be? Good, so I'm going to go ahead and just write it as SU is congruent to SU. Because remember, I'm representing 2 triangles. So if you want 1, 2, 3, make 3 marks for that line because it's a congruent line. Now I have to find my angles. So now I have to find 3 congruent angle pairs. And looking at the obvious one, which one's the obvious one? I have my right angles. I have U, angle, I'm sorry, not U, angle V is congruent to angle T. Please be aware you have to have prior knowledge of lessons we've learned. We covered perpendicular lines theorem. Perpendicular lines theorem, I'll jog your memory. Hopefully we remember what it was. Two lines are parallel if they have a perpendicular. Okay, two lines are parallel when they're perpendicular to each other. So they're giving me those perpendicular angles. So when I'm looking at it, these are two lines, two parallel lines cut by a transversal. Okay, again, prior knowledge that we should have, information we should already know. So when I'm looking at this, I am able to state angle 1 is congruent to angle 4. Why would they be congruent? What am I using? Alternate what? Good. Alternate interior angles. And angle 2 is congruent to angle 3. These are using alternate interior angles. You have to use information that we already know. It's not like you can forget it and move on. You have to know information from previous chapters. So this is alternate interior angles. Again, if they're perpendicular, they're parallel. And we covered that. You guys had that so many times on there. Perpendicular lines theorem. It was what? Perpendicular to a transversal. So looking at this, I stated 3 sides and I stated my 3 angles. Are these triangles congruent? Yes, they are. So looking at it, I can state that yes, it's the same size and shape. S-H-A-P-E. These triangles, they're congruent triangles. Okay, in order for them to be congruent, you have to state the size. This should be a Z. Same size and same shape. Yeah.
You know last year my math finder got 96.
That was algebra though. Same size, same shape. All right, this one is a proof, but it is not a hard proof. They're already giving us a lot of information. So I'm going to write my 2-column proof. I am going to have my statements and my reasons. Go ahead and write it yourself. And we're going to write this one out. So, statements, reasons. What is my first statement? Let me actually scoot this line over. What's my first statement? Or what's my first reason? My given, so I'm going to write everything down that's given. So SV is congruent to RV. TV is congruent to WV. ST is congruent to RW. And I'm going to write this angle symbol over here. Angle T is congruent to angle W. This is one of the easier proofs, sorry. And what's my reason for this? Anybody know what the reason would be for this information? Given. All right, when I say it's super important you label in geometry, you have to label these. So looking at the image on the side, SV, I'm going to label it with one tick mark, is congruent to RV. Those are the same. TV is congruent to WV. And ST is congruent to WR. So they basically gave us all three sides. Now I need to find all three angles, and they're also giving me one angle. The angle they're giving me is ST is congruent to, I'm going to write one curve, angle W. Angle T is congruent to angle W. So that's the information that I have. So looking at this diagram, who could tell me the information for one angle? Which angle is congruent?
Angle T and angle E.
Angle what?
T and angle W.
Okay, that was given though. What do we already know?
Yeah, we're not.
That was given, but we have to figure something else out. So this was given, so now I need to come up with another step, another statement, and another reason.
S is congruent to R.
How? Can I just assume that angle S is congruent to R? I cannot. But what do we know about vertical angles? V is congruent to V, and how do I know that? They're vertical angles, but I can't state it as V is congruent to V. For this one, you have to state it using 3 letters. So how would I state it for the angle? How would I state that?
Angle SVT is congruent to WVR.
Okay, so I have to follow my congruency marks. So yes, we can say angle STV is congruent to, what would match with my S and what would match with my T? If T is already congruent to W, my T and my W have to be in the same place. It's actually SVT. I wrote that wrong. So it is SVT because we're specifically talking about angle V. So it's SVT. So how would I write my other angle? RVW. RVW. So when I'm looking at it, I'm going to highlight which ones are which. S is with my R because we stated W and T, and then S is by itself. So I highlighted them the wrong colors, so I'm going to switch them. So S and R together because there's nothing there. And then T and W are together because we already made a congruency mark. So vertical angles congruent theorem. That's what I used. Vertical angles, VAT, vertical angles congruent theorem. I'll write it out just so you guys have it. Okay, my vertical angles. So now I'm going to write my vertical angles. These are my vertical angles right here, and I'm going to use 2 congruency marks. Now, we learned a theorem today. What was that theorem called?
The third angle
Theorem. Good, perfect. So because I have 2 angles, I can already know what the third one is. So, step 3. I'll do it in purple. My third one is angle S is congruent to angle R, and my reason, Natalie stated it, is third.
Who stated it?
Natalia stated it. My third angles, not triangle, theorem. That's a T, and there's my M. Natalia stated that is third angle's congruency theorem. So she should know this on the test.
Chung, I don't do good on your test.
It'll be multiple choice. For this one, you'll have multiple choice to fill it in.
But how did I go below number zero?
I'll go over it so you know all the answers. All right, I'm not done because I have to state the ending. Triangle STV. This is it. For triangle STV is congruent to triangle RWV. By definition of congruent triangles. Definition of congruent triangles, I stated that all angles are congruent and all sides are congruent. I stated all three sides and all three angles. Go ahead and submit them. All right, your test is Thursday.